waveguide junctions, hybrid rings, series on microwave engineering, lecture number 1.17. Hybrid rings, also known as rat race circuits or rat race couplers, or microwave junctions. Like any other junction, they are also used either to split a wave or to combine waves. As divider, as wave splitter, it takes a wave as input and divides the wave into two equal halves. The outputs are usually in phase, but it is possible to configure the device such that the outputs exhibit 180 degrees phase difference. In this class of devices, waveguide versions are available, coaxial line versions are available, microstrip line versions are also available. In waveguide versions, two types are there. One type uses series junctions, another type uses parallel junctions in their construction. In the present session, the focus is on waveguide versions of the hybrid rings or rate couplers. Now, let us move further to have a discussion with a view to understand the functioning of these devices somewhat deeply and clearly. A few points are given here as an introduction to hybrid rings. Hybrid ring or rat race circuit is a 4-port. It has 4 ports. 3 dB coupler consisting of a transmission line ring connected with 4 lines at specific intervals. This point gives good amount of information regarding the structure, the physical appearance of hybrid rings. These can be fabricated either with sections of rectangular waveguides or coaxial lines or planar lines. In waveguide implementation, essentially, they consist of a waveguide ring having a mean circumferential length of 1.5 lambda g. Lambda g is a symbol for guide wavelength, capable of sustaining standing waves. When it is functioning, hybrid rings hold standing waves. 4 waveguide sections or arms are connected to the ring at proper intervals. Here are shown hybrid rings. In A is shown H-plane hybrid ring. In B is shown E-plane hybrid ring. First, we concentrate on A, how this structure has come into being. Take a piece of waveguide, rectangular waveguide, like this, and bend it, forming a ring. There are 2 possibilities for bending. Bending can be in a horizontal plane or H-plane. Bending can be in vertical plane or E-plane too. If the bending is in horizontal plane, we get a ring that is shown in A. If the bending is in vertical plane, we get a ring that is shown in B. As bending is in H-plane, the ring in A is H-plane ring, whereas the bending is in E-plane for the ring shown in B. That's why it is called E-plane ring. The length of the piece, rectangular waveguide piece, it should be such that the mean circumferential length of the ring should be 1.5 lambda g, 1.5 guide wavelength. Now, in these rings, one has to make 4 slots and pieces of waveguides, rectangular waveguides. They are to be attached to the ring covering these slots. 4 slots, 4 arms. In case of H-plane ring, which is shown in A, these 4 arms, they are having a distance of lambda g by 4 between them, between consecutive arms, except between 2 arms, which are at a distance of 3 lambda g by 4. It is the case same in E-plane ring also. The 4 arms, they are having a distance of lambda g by 4 between them, but are except 2 arms which are having a distance of 3 lambda g by 4. One can notice in case of H-plane ring, attaching arms forms parallel junctions. In case of E-plane ring, attaching arms forms series junctions. Notice in the waveguides, rectangular waveguides that are used, the distance between narrow walls, it is indicated by A. The height of the waveguide is indicated by B. These are standard symbols, A and B. But also, A is nearly twice of B. This aspect requires to be kept in mind. In these diagrams A and B, port numbering is also given. Port 1 and port 4, their junctions, they are at a distance of 3 lambda g by 4. In B also, it is 3 lambda g by 4. Junctions of port 1, port 2. Junctions of port 2, port 3. Junctions of port 3, port 4. In both the cases, they are at a distance of lambda g by 4. We better keep this port numbering in mind because properties of hybrid rings, they are going to be given in terms of this particular port numbering. Some more points. The rat race can be designed to have either parallel or series junctions. In case of parallel junction ring, the structural arrangement usually consists of a piece of rectangular waveguide bent in H-plane to form a complete loop whose median circumference is 1.5 lambda g. Lambda g stands for guide wavelength. 4 openings are made in the outer narrow wall of the ring and 4 waveguide arms are connected to the openings, forming parallel junction. If there are no reflections from the terminations in any one of the arms, then any one arm is coupled to 2 others but not to the 4th. It implies you give input at the port of an arm, it appears at the ports of 2 arms, but nothing at the port of the remaining arm. Hybrid rings, they are also constructed by bending the waveguide in E-plane and providing connections with series junctions. In the case of hybrid ring with parallel junctions, for matching purpose, the waveguide ring should have a characteristic impedance equal to root 2 Z0. In case of series junctions, it should be Z0 by root 2, where Z0 is characteristic impedance of the connecting arms. After describing the structural features of waveguide version hybrid rings, now we move to a description of the properties. Under ideal conditions, with respect to the port numbering given in figure, hybrid rings exhibit the following property. First one, all ports are perfectly matched to the junction. Port matched to the junction means if you give an input at this port, the entire input goes into the junction and nothing out of it gets reflected back towards the port. In the present case, in the case of hybrid rings, all ports are perfectly matched to the junction. Ports 1 and 3 are decoupled, as are ports 2 and 4. The port 1 is matched to the junction when ports 2 and 4 are match terminated. Similarly, port 4 is matched to the junction when ports 1 and 3 are match terminated. So, ports matching to the junction is conditional. Port 1 is matched to the junction only when 2 and 4 are match terminated. Otherwise, 1 is not completely matched to the junction. Similarly, port 4, port 3, port 2 also. These relations hold good only when Ci of the ring, characteristic impedance of the ring, is equal to root 2 Z0 in case of parallel junctions and Z0 by root 2 in case of series junctions. some more properties. The wave at the output ports exhibit a phase difference of 180 degrees or 0. If the input is at port 1 or 4, the outputs appear at ports 2 and 4 or 1 and 3 respectively and differ in phase by 180 degrees. Phase difference between outputs is 0 when the input is at port 2 or 3. In this case, outputs appear at ports 1 and 3 or 2 and 4 respectively. A signal entering either port 1 or 3 splits equally between ports 2 and 4, while a signal input at port 2 or 4 splits equally between 1 and 3. The input power splits equally between the output ports, equally half-half. If you give 1 watt wave as input, outputs will be half watt. Half is equal to 3 in dB. That's why this is called 3 dB splitter. If the input is connected to port 1, equal amount of output powers appear at ports 2 and 4 with no power at port 3. For this reason, this device is called 3 dB splitter. It is also possible to design a non-3 dB splitter by making each lambda by 4 section of the ring alternately of low and high impedances. It can produce a sum and a difference signal from two input signals given at ports 1 and 3. The sum signal appears at port 2 and the difference signal appears at port 4. Hybrid ring, it is mentioned, is a junction. As it is a junction, it can be used either to split the signal, that is, as a divider. It can also be used to combine two signals. Its functioning, its working, its behavior, when it is used as combiner, is being described in the last point of this slide. Functioning. Hybrid ring has the characteristics similar to hybrid tea. Hybrid tea is magic tea. Lot of similarity is there between hybrid ring and hybrid tea. Both are having 4 ports. All the 4 ports are matched to the junction. There exist certain ports which are isolated from each other in both the devices. Both devices divide wave into 2 equal halves. Both devices are capable of giving in phase as well as out of phase outputs. So many similarities. Wave fed into port 1 cannot appear at port 3 because the difference of phase shifts at this port for the waves traveling in clockwise and counterclockwise directions is 180 degrees, thereby cancelling each other. The wave after entering into the junction from port 1 splits into 2 equal parts. One part travels in clockwise direction, another part anti-clockwise direction. By the time these waves reach port 3, they have a phase difference of 180 degrees, a path difference of half wavelength. It leads to cancellation, cancelling each other, nullifying each other. Hence, nothing appears at port 3. It results in a standing wave in the ring with a node at port 3. Similarly, the wave fed into port 2 cannot appear at port 4, and wave fed into port 3 cannot emerge at port 1. Principle is same. Input gets split into 2 equal parts, and by the time these 2 waves reach the decoupled port, they acquire a phase difference of 180 degrees. They acquire a path difference of half wavelength, cancelling each other. Hence, wave cannot come out of the decoupled port. Perfect cancellation, however, takes place only in ideal hybrid rings and at a designated frequency. At other frequencies, cancellation is not perfect, and there exists always some residual wave, however small it may be. In actual hybrids, there exists always a small amount of leakage resulting in non-zero wave at the isolated port or decoupled port. The useful bandwidth of the hybrid ring is highly limited. For most applications, it is only 20%. Now, a few points regarding the similarity, the differences of hybrid ring with hybrid T. The rat race coupler used in microwave systems is an alternative to magic T. These two can be used interchangeably in several applications. However, they differ from each other in the following counts. Hybridity is less bulky but requires internal matching. This is a serious problem which does not require for hybrid ring if the thickness is properly chosen. Hybrid ring seems to be preferable at higher frequencies since its dimensions are less critical. In contrast to magic T, the two-dimensional structure of rat race makes it more readily amenable for construction in planar technologies such as microstrip and strip line. So the basic point to understand here is hybrid ring and magic T. They are useful. They are used in microwave systems and their functioning is such that they can be used interchangeably. However, hybrid rings, they are at an advantage when compared to magic teas when it comes to implementing them in integrated circuit technology. There, magic tea is difficult for implementation. These are some of the points which I want to share with you for right now. To recap, here in the present session, we considered rat race couplers. The structural features, the electrical properties are given along with a comparison with magic T junctions. Hope you have a beautiful and wonderful, a successful and fruitful and enriching and enchanting learning experience. Enough for now. See you soon again. Bye bye.